Now it is the second scenario where axes are inclined of the shaft. So I will play it.
Output shaft turn along a vertical plane.
You see how is this how is the motion of different arms is taking place. Okay, say it is horizontal arm and it is vertical arm. So how they are being rotated? So one arm is rotating in vertical plane, which is shown by green line,
While the red ends, which are connected to the output shaft, have to move along a different plane. To make the red
see the plane is different of the uh, second cross. These two planes are not perpendicular to each other. No, in earlier case, when the axes were collinear, okay, at that time both the arms were turning in the same plane, that is green plane. लेकिन अभी क्या हो रहा है कि second arm has to turn in different plane, means its plane is inclined. Okay,
red ends move along the inclined plane, the cross has to spin along the axis connecting the green ends. If you observe the mark on the cross, if you
see now what you have to do, these lines have been marked, blue lines. You have to see the motion of these lines, what is happening to this arm. You will find that this arm is also turning about its own axis. Okay,
observe the mark on the cross, you can see this phenomenon.
see these lines are turning.
To make the cross spin concept clearer,
So in some revolution it is turning forward, and in the remaining revolution it is turning backward, because it has to come back to its original position when revolution completes. When it turns forward, at that time it adds this motion to the input motion, and you get output motion greater than input motion. When it turns backward, then it subtract this backward motion from the input motion, and you get output motion as less than the input motion.
let's have a look at this hypothetical animation where the spin of the green axis is halted.
See,
It is clear that without
if spin is halted means अगर आपने इसको spin करने से prevent कर दिया, okay, so what will happen?
this spin, the motion of the inclined hook joint is impossible.
The motion of inclined shaft will be impossible because it cannot rotate in that plane. Okay, are you getting it?
Yes, sir.
The spin of the cross makes a huge difference in the speed of the output shaft. It is clear that when the cross is spinning as well as rotating, the velocity of the output shaft will have an added effect. For the first 90 degrees of the input shaft rotation, the green axis spins to its maximum angle. The forward spin aids and changes the output shaft rotation as shown.
See, because of this forward spin, what is happening is that it is the input speed, okay, and it is the output speed. So output speed you are getting more than input speed, okay.
But for the next 90 degrees, it should spin back to the initial zero position. The reverse spin will have an opposite effect on the output shaft rotation. Just by taking a simple time differential of this displacement graph, we can find out speed of the output shaft. It is clear that the output shaft has a fluctuating speed as shown.
So output of the output shaft speed is fluctuating. Input speed is constant, but output shaft speed is fluctuating like this because of this spin getting added into input speed or getting subtracted from the input speed.
This means the universal joint is not a constant velocity joint. This jerky rotation makes the universal joint useless in its original form. But you can make it a constant velocity joint by incorporating.
So when you use a single hook joint, okay, you do not get a constant velocity joint. You get a jerky motion of the output shaft. That is kind of useless motion. Okay, so in order to make use of that, okay, what we do, we use one more. We use double hook joint, and we introduce one intermediate uh, shaft in between that. That is shown here.
One more joint as shown.
See.
If a constant velocity input gives fluctuating output, a fluctuating input will give a constant velocity output. Thus, the double universal joint acts as a constant velocity joint. We hope you have now gained a good understanding of the workings of universal joints.
Okay, so I hope that you got it's working, how it works. Now let us do the some analysis of double hook joint. Sorry, first let us see the single hook joint, and then we will move to the double hook joint. So next, let us come back to slides. Okay, so let us go to the analysis then. So let us first find ratio of shaft velocities. That is, what is this ratio? Omega 1, that is output shaft speed upon omega. You can also call it as N1 upon N. Okay. So first you need to understand this geometry of the uh, hook joint. So here arm AB of the cross is connected to the input shaft. Here you can see it is the front view and it is the top view. Okay. See in top view, you will see that this arm AB of the cross is turning in horizontal plane. Okay. And this arm CD of the cross is turning in an inclined plane as we have seen in the video. Okay. So it is the axis of driven shaft. You can see axis of the driven shaft, and this is the cross with which it is connected. It is the cross AB which is connected to the driving shaft. So it is the axis of driving shaft, this one. This is the axis of driving shaft. So if you see that these two axes are inclined and angle of inclination is alpha. Angle of inclination is alpha. Okay. When you see this in front view, so in front view, when you see the motion of arm AB and CD, just a second, okay. So you will find that if you are looking from the front, you will see that arm AB is rotating in a circular path like this. When you will observe the motion of arm AB, it will be rotating in a circular path. But as arm CD, arm CD is moving in an inclined plane, then you will see that the arm CD is moving in an ellipse, in an elliptical path. Getting it? Because the plane in which arm CD is rotating is inclined to the observer. Okay, if you know the orthographic projections, it is the concept of graphics. Okay, if you will keep a circle inclined to vertical plane, then that circle will appear as an ellipse in front view, if you remember it. Okay, so same you can consider that CD is rotating in circular path, but to you it will appear as if it is rotating in elliptical path. Okay, so here different parameters are: alpha is angle of inclination. Let us consider theta as the input to the driving shaft. You rotate the driving shaft by an angle theta. Okay, so new position of driving shaft, you will observe that it is at point A1 and point B1. It is the new position after it is given an angle theta. And to you, the arm CD will also appear to rotate by angle theta because they are at 90 degree to each other. Okay, so it will appear that even arm CD is also rotated through angle theta, but the length of arm CD will be shortened because it is inclined to you. Okay, it will appear on an ellipse like here. So here you will locate the point C1 and D1. It is the new position of arm CD which is visible to you in front view. Okay, but you know that the plane of the arm CD is inclined to you, and whatever angle of turning is visible to you is not its true angle of turning. Okay, in order to find out its true angle of turning, you have to take projection back from ellipse to circle. Okay, so this point C1 is projected on circle C2 here. Okay, and this C2 point is joined with point O, and then angle is measured. What is the angle of this OC2 from the vertical, from the original position of CD? So you will see that there is angle phi. So angle phi is the turning angle of output shaft, which is greater than theta. Getting this? Yes or no?
Yes, sir.
Okay, so a little uh, concept of graphics is there. Okay, just like that. So C1, when C1 is point is projected on horizontal diameter, we denoted this point as M. When C2 is projected downward, it is we have denoted by N. Okay, and when you take the same point up here, so C1 is on which arm? That is CD. So इस CD पे टॉप व्यू पे उसको प्रोजेक्ट किया है. C1 point is projected on top view. So here you will see point N1. Okay, this is point M, and when you will rotate it like this, so you will find that this point N and this point are coinciding like this. So with the help of this geometry, we will find out different relations. First, we are interested in finding out the ratio of shaft velocity omega 1 upon omega. So you know what that omega 1 is the rate of change, of angular displacement. So rate of change of angular displacement of output angle, output shaft ka angle, that is nothing but d phi. Its rate of change with respect to time is omega 1. Similarly, omega is the input velocity. Input velocity omega can be written as a rate of change of input angle. Input angle is what? Input angle is theta, d theta upon dt. Okay, we want to find out relation between these two. Okay, so now let us see in triangle OC1M. So see, where is the triangle OC1M? This triangle OC1M. Okay, so what you can write is tan theta. So here tan theta will be equal to, just a second, note it. Okay, where is tan theta? Tan theta is this distance. This distance is nothing but OM. OM. Okay, this distance upon this distance. So what is this distance? This distance is equal to C1M. So equation is written as OM upon MC1. Getting this? Tan theta is same. Similarly, you can write for tan phi. तो tan phi के लिए क्या लिख सकते हैं यहाँ पे? tan phi, for tan phi this distance C2 से ये यहाँ का डिस्टेंस कितना हो गया? ON. Okay, upon this distance again, so C2N is equal to C1M. So further we can write tan phi is equal to ON. See, as this angle is phi, this angle will also be phi. यहाँ पे भी एंगल phi होगा. So ON upon MC1. It is the second equation. Now let us further simplify it. Are you getting this equation or not?
Yes.
Okay. So let me clear all drawings. So one can easily see, as this is angle theta, this angle is also theta. This angle is also theta. As this angle is phi here, so this angle is also phi. So these two equation, we want relation between theta and phi. So we can take ratio tan theta upon tan phi. You write this ratio here OM upon MC1 into tan phi. Tan phi is equal to this ON upon MC1. So it will, as it is in division, it will get inverted MC1 upon ON. MC1 will get cancelled and you will get OM upon ON. So you see carefully what is OM and ON. So see, OM is this distance here and ON is this distance. So what is relation between OM and ON? You look at the top view. See, ON here, ON is equal to ON1. Okay, and ON1 and OM are related with this alpha. What that ratio will be there? Cosine ratio or what? Cos alpha क्या होगा? Cos alpha will be OM upon ON1, right? So we can write OM as ON1 cos alpha, OM as ON1 cos alpha is equal to ON cos alpha, because ON1, this is same as ON here. So put the value of OM as ON cos alpha here. So ON will get cancelled, and you will get a relation tan theta is equal to cos alpha into tan phi. Okay, it is the equation you can note down between the input angle and output angle, and output angle in terms of alpha. So you can see that phi is not constant. Okay, write down this. No, phi is not equal to theta. That is the conclusion from it. Write down this relation tan theta equal to tan phi into cos alpha.
Done, sir.
Okay. So we know relation between tan theta and tan phi, that is theta and phi. So we can establish a relation between, uh, you know, what we can say, theta is nothing but input angle omega, and phi is the output angle omega 1. So in order to have omega and omega 1 relation, you need to differentiate this equation with respect to time. So take derivative on both the side. Here theta will change, like as your shaft will rotate, the theta will change from 0 to 360 degree, right? Similarly phi will change, but alpha is the angle of inclination between two axes. So cos alpha will remain constant. This is a constant factor. दिस शाफ्ट का जो एंगल ऑफ इंक्लिनेशन है वो कांस्टेंट रहेगा. सो कॉस अल्फा इज कांस्टेंट. नाउ यू टेक डेरिवेटिव ऑफ बोथ द साइड with respect to time. See what you get. Take derivative. So as I told you, omega is angular velocity of driving shaft d theta upon dt. Omega 1 angular velocity of the driven shaft. So that equation you differentiate. Let us see what you find. Tan theta, tan theta is equal to tan phi into cos alpha. So डेरिवेटिव ऑफ tan theta कितना होता है?
6 square theta.
Sec square theta. So it is written here, sec square theta. Okay, but again we have to differentiate theta with respect to time. Okay, because of chain rule, tan was not the function of time. If it was tan t, answer would have been sec square t, but it is not tan t, it is the tan theta, where theta is again a function of time. So we have to again differentiate theta with respect to time. So then we get this term d theta upon dt. Similarly here cos alpha into sec square phi into d phi upon dt. So here in place of d phi upon dt you can keep omega 1 and in place of d theta upon dt you can place omega. Okay, so your equation will look like this: omega 1 अपॉन ओमेगा, ये ओमेगा है, ये ओमेगा 1 है, so it will look like sec square theta upon this term cos alpha into sec square phi 1 upon, so sec square theta is written as 1 upon cos square theta. You know, sec square theta is equal to 1 upon cos square theta. Here it is written like this. Are you understanding? You
Yes, sir.
you have to practice it, okay, many times, so that you will memorize this. Steps are clear. You differentiate it means you know the differentiation. Next step will come automatically. Okay, after that you have to just rearrange the terms. Okay, so here it is 1 upon cos square theta into cos alpha into sec square phi. So again it is simplified further. This sec square phi, you see here, this sec square phi is simplified further. So you know this relation of trigonometry: sec square phi is equal to 1 plus tan square phi. Then you know the relation of tan phi with tan theta. So tan phi is equal to tan theta upon cos alpha. पहले ही हमने ये relation establish किया है. Okay, that is your tan theta. Tan theta is equal to tan phi. Tan theta is equal to tan phi into cos alpha into cos alpha. So using this relation, we have put the value of tan square phi as tan square theta upon cos square alpha. Then it is further simplified. Tan square theta is kept as sin upon cos. Okay. Then it is multiplied here. You get kind of this expression. Okay. Then here cos square alpha is kept as 1 minus sin square alpha. So it expands in this way. Here cos square theta plus sin square theta is 1. 1 minus cos square theta into sin square alpha, like this. And this value of sec square phi, this value of sec square phi is kept here. यहाँ पे रखोगे आप, तो कैसे दिखेगा ये इसमें, यहाँ पर ये जो डिनोमिनेटर है ये ऊपर आ जाएगा, न्यूमरेटर में चला जाएगा. न्यूमरेटर में क्या दिखेंगे आपको? cos square theta into cos square alpha. तो cos square theta will get cancelled and 1 power of cos alpha will get cancelled here. Okay. So you write it down. Should we continue now? 354. So only we will stop ओमेगा 1 और ओमेगा का रिलेशन देख लेते हैं और फिर हम स्टॉप करेंगे. आर यू गेटिंग दिस ट्रिग्नोमेट्री फॉर्मूली?
Yes, sir.
Okay. You need to do practice. Okay. Next. So that value is kept and it is further simplified in this way. So it is the relation, this one, omega 1 upon omega is cos alpha upon 1 minus cos square theta into sin square alpha. This relation you get this velocity ratio only in terms of one variable, that is theta. Theta is variable, this alpha is constant. Okay, so we have eliminated what? We have eliminated the phi from the equation phi. Okay, and we have come to this relation. Omega 1 is nothing but 2 pi n1 upon 60. Omega is 2 pi n upon 60. So it can be written as n1 upon n cos alpha upon 1 minus cos square theta sin square alpha. So you note it down. Any doubt you have, you can ask. Here we will stop. We will continue the same topic in next practical. And maybe we are going to start a new module in next practical. Maybe, could be, which is tomorrow only, right? Tomorrow is the com slot. Any doubt or any other thing you want to ask?
No, sir.
So note down this formula n1 upon n. Otherwise, omega 1 upon omega is equal to cos alpha upon 1 minus cos square theta sin square. Then you can leave after noting down.
Done, sir.
Okay, so you can leave now. You can leave the meeting.
Yes, sir.
Okay.